Hi, welcome to this course on Python, and in this video we shall be talking about one of the most important library. This is nothing but NumPy. Well, what exactly is NumPy? Num stands for numerical and Py stands for Python. And this library is used for all the numerical operations. And this library is used mostly for the data analytics and data science activities which we do. For an example, you are extracting some data, you are reading a data. Now we already know that we read data using pandas library, and after reading data, your data could have categorical features, it could have numerical features as well. Now how can we deal with the numerical features? Sometimes we might have to do some transformations on numerical features, so there could be a lot of activities which can be done on numerical features or numerical variables. In that case, NumPy is used. Well, NumPy can be used to store data of different forms. It could be one dimensional, two dimensional, or n dimensional. But the question is, why do we use NumPy? Because traditionally speaking, we already have gone through various for loop conditions. We know what is list comprehension, we know what is map functions. Now these kind of things can also deal with numerical variables. Why do we use NumPy? It all depends upon the type of data, and if you are dealing with big data, your traditional approaches might take a lot of time. NumPy is way faster as compared to the traditional approaches. You can see in this graph the time taken for various loops. Plain for loop takes the maximum amount of time because it's a very traditional approach. It goes through each and every item iteratively. Then comes list comprehension. Then comes map function, and NumPy is seen or has been experienced to be the most effective when it comes to time taken. Now, what is NumPy? We already discussed the basics. It's a library used for computation and processing of single and multi-dimensional arrays of elements. Smaller memory consumption and better runtime behavior. Installation of NumPy is very simple. These days, with the latest Python versions, NumPy, Pandas, Matplotlib, they come predefined, like they are pre-installed in those Python modules itself. But in worst case, if NumPy is not installed, when you are importing NumPy library and you are getting an error, you can simply install using the command pip install NumPy. You can run this command over your command line in your Anaconda prompt, Jupyter Notebook consoles, or your Spider Notebook consoles. And after this, your NumPy will be installed and you are ready to start installing or start using the NumPy library. So this is all about the theoretical concepts. We'll jump onto the practicals part now. As we already talked about NumPy, NumPy is nothing but a Python library and it stands for numerical Python. We already discussed that it is used for working with arrays, it is used for computation and processing of single and multi-dimensional array of elements, and smaller memory consumption and better runtime behavior. To install NumPy, you have to do pip install NumPy and then start using by importing the library. But usually whenever we import NumPy, we do it like this: import NumPy as np, so that we don't have to call NumPy again and again. So np acts like an alias here as np. So whenever you import NumPy, you can simply do np dot your method name, NumPy will be called. So there is a funny meme: I don't always import NumPy. Whenever I do it as np. Image courtesy goes to memegenerator.net, from where I extracted this image. Now let's get started with the practicals part. So here I'm creating an array. So how to create an array? It's very simple. Creating an array. Okay. So NumPy, which is np dot array 1 2 3. So these are the three elements, and here I'm doing print of a. If I run this, okay, NumPy is not imported, so we'll import this and then we'll run this. Now you can see this is what my a looks like. It's an array. If you want to see what is the type of it, type will be NumPy array. you can see NumPy dot ND array. What is this? This is nothing but n dimensional array. Okay, this is the type of NumPy array. So it could be a one dimensional array, it could be a two dimensional array. Let's say you're defining like this. So this will also be an array, but it's a two dimensional array. The type will remain the same. It's going to be ND array. But the interpreter already knows that it's a two dimensional array. Now let's say I'm defining the same data type, like the same numbers 1 to 3, but I want to define it as float objects. Here it is defined as integers. What we can do is we can simply pass d type equals to float, which basically means data type equals to float. If I run this, now my A looks like this. Now if I want to create data type as string, will this work? Or str, will this work? Yes, it will work. You can see the three elements are string objects 1, 2, and 3. Now, if you want to find the length of an array, you can simply type len function length of your object, and then it shows you 3. That means it has 3 elements. Now, let's say I'm defining a two-dimensional array. You can see one dimension. Your first element is 1, 2, 3. Second dimension 4, 5, 6, like the second element. Now if I run this, this is how my B will be. Now if you want to type the length of B, it will be 2. Why? Because there are two objects. Each object is a list. So you are forming a list of list. So that is the reason the length of B is 2 here. First and second. Okay, it will not be like 1, 2, 3, 4, 5, 6. If you don't define like this, if you define it this way, let's say like this, sorry, 6, and in this case if I want to length of B, it will return you 6 because there are 6 elements, but here there are 2 elements, 1 and 2. Okay, similarly, how to type the type of B? Here I am creating another array, and this time I am going to create 3 objects, 3 elements, 1, 2 and 3. If I run this, and now if I run length of C, it will return me 3. Now one thing is, here let's say my A is 1, 2, 3. My type is ND array, but you want to see how much dimensions your type is, like how much dimension this array has. What you can simply do is you can simply type in dim of A. It will give you, sorry, my bad, A dot ndim. Okay, A dot ndim. If you run this, it shows you that this is a two-dimensional array. Similarly, we can run it here. C dot ndim. You can see C is of 2 dimensions, right? There are 3 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the dimensions of C is nothing but 2. Similarly, dimensions of B is 1. What is B? B is this one, right? So to check the number of dimensions, you use the object dot ndim. Similarly, I am creating a 4-dimensional object 1, 2, 3, 4, and then if I do d dot ndim, it is returning me 4. Why use NumPy? Well, somehow we already discussed this. The main reason why we use is it's having a faster computation time. It is way too faster as compared to the previous approaches. So, in traditional Python programming, we have lists that serve the purpose of arrays, but they are slow to process. Because so far, when we created all these arrays, you might be thinking that we already have lists in traditional programming. We already have tuples. Why don't we use that? Why do we have NumPy? So, in traditional Python programming, we have lists that serve the purpose of arrays, but they are slow to process. NumPy aims to provide an array object that is up to 50 times faster than traditional Python lists. And uh, this is what they claim, NumPy claims. But with personal experience, I can say that it's way too faster. as compared to the traditional lists. I haven't calculated whether it is 50 times faster or not, but it is way too faster. But this is what NumPy library claims. They claim to be 50 times faster than the traditional Python lists. The array object in NumPy is called ND n dimensions array. It provides a lot of supporting functions that make working with ND array very easy. There are so many methods inside your NumPy library that you will be lost. I will not be able to cover each and everything, but I will try to cover as much as possible. As much frequent methods that we use on day-to-day activities, I will be covering all those basic methods. Arrays are very frequently used in data science, where speed and resources are very important. Because when it comes to data analytics and data science, we deal with huge amount of data, right? Big data. So in that case, your traditional programming will not be able to help you out. So NumPy is mostly used. Can be used to store 1D, 2D, 3D and so on. Time taken for the loop. We have already gone through these things. Now, we'll talk about some other methods. There is one more method called as shape. Shape basically tells you how many rows and how many columns do you have. Now let's say your A is like this. So the shape is 1, comma 3. Okay, your B is like this. The B dot shape is going to be 6 because you have 6 elements. Here you have one element. Inside one element you have 3 elements, right? So your shape is 1 comma 3. C looks like this. So C will have 2 comma 3. Sorry, 3 comma 3 because there are 3 elements. My bad. 3 elements, and within these 3 elements there are 3 entities. Okay. So if you want to find the data type of a particular NumPy variable, you can simply type in a dot d type or else b dot d type. This will tell you the data type. Okay. So moving on to the next one, let's say I have an array 1.1, 2.1, 3.4, and here I'm printing it. So these are the basic things which we have already covered. Now, the next important thing in NumPy will be accessing or changing specific elements, rows and columns. So these are some concepts which we are going to right now. Once we jump into some real-time data, some real-time projects, then you will have a better understanding on where and how to use NumPy operations. Okay. In this video, we are just focusing on the various methods that we have inside NumPy. Now, accessing or changing specific elements, rows and columns. Here I've defined a equals to numpy.array something 1 2 3 4 5 6 7 8 9 something something. So if I print my a, this is how my a looks like. What is a? A has 2 dimensions, right? What will be the shape of a? It's going to be 2 comma 1 2 3 4 5 6 7, 2 comma 7. Okay. Now let's say you want to get a specific element. We will be using 0 comma 3. What is 0 comma 3? You can see 0 is basically means the first index. Python indexing starts from 0, and then 3, that means 0 1 2 3. So 0 comma 3 is basically 0th entity. Inside that 0th entity you are getting the third index. So 0 1 2 3. Now if you want to print 12, what it will be? If you want to print 12, so it will be 1 1 comma 0 1 2 3 4. It should be 1 comma 4. If you print, then it is showing you 12, right? What will be 1 comma 0? It will be 8. First index, so 0th index, first index, and inside first index the 0th index, 1 comma 4. So it's super simple. It's very simple to understand. Get a specific row. Let's say out of this you want to print the entire row. That means 0 colon nothing. That means all the entities from the first row, 0 colon this one. You want a specific column, let's say you want this column 3 10, so colon 2, something like this. Colon 0 is basically printing you 1 8. If you want to do colon 2, it will print you 0 1 2. So 3 and 10, it will print you 3 and 10. Where is colon 2? 3 and 10. Okay, so this is how you access your different operations. Now this is your array. Let's say you want to access some elements and you want to change the values. Let's say you want to change this attribute. What is this attribute? You can simply access this attribute by 0 0 1 2 3 0 comma 3. This is 4. Now if you do this equals to 40, like I am doing here in this line, if I do this and then print a, you can see the elements have changed. So NumPy arrays are mutable in nature. You can change it. Now change the fifth column in first row to 50. Simply fifth column and first row. So 0th index 0, fifth column. So 0 1 2 3 4, 0 comma 4 equals to 50. After this, we'll be talking about some zeros and ones method in NumPy. There are some zeros and ones method. So in case you want to create a NumPy array with all zero entities, like all the elements will have zeros. Why do we do that? There are specific scenarios where we use these kind of logics. So we do have some functions like zeros, ones, and something like full. Now if I call numpy.zeros, then I call the dimensions 3 comma 3, that will give me a 3 comma 3 matrix. So a 3 cross 3 matrix with all zero entities. You can see if I'm printing it, I'm getting the values as 0 0 0 0 0, but these values are in float format. How can we change it to integer? You can change it like this. Oh, zeros, sorry, my bad, spelling mistake. Now you can see all have integer values. Is string possible? Well, string is also possible, but it's not showing you any value because 0 is basically null in terms of string, right? Similarly, if you want to print a 3 cross 3 1 matrix, you can do np.ones. And if you want to have the data type as integer, pass the d type equals to int 32. If you are not passing int 32, you are passing int, that also works. Okay, so this or this, both are same. Okay, similarly float 64 or float, both are same. Now after zeros and ones, the next method is going to be full. What is full? Full is, let's say you want to create a matrix of a single number, all the entities will have the same number. In that case you can use np.full. You are passing I need a 3 cross 3 matrix and the value should be 50. Or else let's say you are defining a variable where a equals to 20 and then you are passing this var a. See, 20. If you are changing it to integer, it will have integer, something like that. So if you pass it or if you hard code it, it's going to be same. So np.full creates a full array of a number which you pass. If you want to create a numpy array of a random number, you can pass np.random.rand, 4, 4. So this will give you a random matrix and all these numbers inside your numpy array will have a number between 0 to 1. But if you want a random integer, you can do .random.rand int. Here it is float and here it is random. Here I'm passing -4 1, which means I want in the range of this. If I don't pass this, it will fail because rand int takes at least one positional argument. So if you pass this, which basically means I want the random values to be in the range of -4 to 1. let's say 1 to 5, and your values will be within 1 to 5. 1 to 100 will be within 1 to 100, right? Let's say I want from minus 5 to 0, so minus 5 to 0. And then we have another function called as identity. I hope everybody knows about identity matrix. 0 1 0 1. This is identity matrix. I hope everybody knows about this. Now to create an identity matrix, you pass np.identity5, np.identity3, which will be 0, 1 0 0 0 1 0 0 0 1. Identity 5 will be 1 4 zeros, 0 1 3 zeros, 0 0 1 0 0 0 0 0 1 0 0 0 0 0 1. Okay, this is the identity matrix. Now there are some practice questions to talk about. Let's say extract all the first 3 rows of the last 5 columns in a given NumPy array A. So this is the array which has been given. Okay, this is not the array. This is the array. Okay, 1 2 3 4 5 6 10 20 something something something. Extract all the first 3 rows. That means all these 3 rows of the last 5 columns. Okay, first 3 rows of the last 5 columns. So your output should be like this. Okay, so that was the output that was mentioned. Output should be this, then this, then this. This should be the output. Okay, how can we do that? So here we have defined my A. My A looks like this. Now, how many rows do we need? We need the top 3 rows. So 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5. I hope everybody knows about the indexing in Python. Your indexes start from 0 from the beginning, and from the end it starts from minus 1, right? So similarly, what I'm doing is 0, 1, 2, 3, 4. So 0, 1, 2, 3. So here I'm passing 0 colon 3, that means colon 3, and I'm passing minus 5 colon something. So here if I run this, it is throwing me the output which is expected like this. Okay, 0 1 2 3 4 5 minus 1 minus 2 minus 3 minus 4 minus 5. So you can see from minus 5 till end, from minus 5 till end, and here till 3, that means 0 1 2 0 1 2 3. Okay, so this is for the rows and this is for the columns. We want 3 rows and we want this much. And if you want to do this, will this work? Like I want to do 0 comma 3, this will also work. So blank is nothing but 0. Okay, if you just want to print the first 3 rows, this is how we do the first 3 rows, right? A 0 colon 3. From the first 3 rows you want the last 5 columns. So minus 0 1 2 3 4 5, from end minus 1 minus 2 minus 3 minus 4 minus 5. So here I'm doing minus 5 colon minus 1. So this will also work. Oh, minus 1 doesn't work. Okay, minus 1 empty. My bad. So there should be a comma here. Minus 5 colon minus 1. So this will also work, and if you are not passing anything, the end attribute here and here, this will also work. Second question is, given a positive number n greater than 2, create a NumPy array of size n cross n with all zeros and ones such that the ones make a shape of plus. So the input is 3, your output should be like this. That means you can see the 1 is formed as a plus, 0 1 0 1 1 1 0 1 0. It's forming a plus, right? If you are passing 5, this is forming a plus, right? So the middle, let's say you have 5 rows, the middle row will have all the values as 1 and the middle column will have all the values as 1, right? So let's say I'm passing n equals to 5. Here I'm creating a numpy dot zeros, so all my entities are zeros. Now here I'm passing n slash slash 2 colon equals to 1 and colon n slash slash 2. What is slash slash? I hope everybody knows about this. Let's say 5 slash slash 2 is nothing but 2, right? 4 slash slash 2 will be 2. So 100 divided by 5 is 20, right? 101 divided by 5 is 20 point something. So your absolute value is basically this one. This is basically your operation. Now here what I'm doing is 5 slash slash 2 is basically 2. So I'm passing 2 comma colon and then colon comma 2. So for all the middle rows and the middle columns it should be 1. And now if I print this, my middle rows and my middle columns are 1. So these are some basic operations. Apart from that, there are some arithmetic operations as well. This is another exercise. We'll be leaving this document to you so that you can practice. There are some various arithmetic operations which we should talk about as well. So let's say here we have defined an NumPy array, np.array 1, 2, 3, 4. Let's say you want to add two numbers, like you want to add 2 with each and every element. How can we do that? Simply do a plus 2. So a plus 2 is nothing but all the entities are added with 2. Similarly, a to the power of 3, that means 1 to the power of 3 is 1, 2 to the power of 3 is 8, so 3 to the power of 3 is 27. If you print this, so each and every entity in your array is getting that mathematical operation. It is doing that mathematical operation. So we also have mean, max, all these functions as well in array. Let's say a dot mean will give you a dot mean, np dot mean a. So both these operations are giving you the minimum values. We also have a dot max or numpy dot max a. A dot mean will give you 2.5. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, divided by 4, 2.5. So the mean value is 2.5. You can also calculate mean using np dot mean of a. Okay. Similarly, we have created another two-dimensional array, a dot ndim. It's 2 dimensions. What will be max element? Max element is 8. Max of a is 8. A of max is 8. Both are same. So these are some NumPy operations, arithmetic operations that you can perform, and it's all about practice. The more you practice, the more you understand about these concepts and when and where to use this NumPy libraries and pandas libraries. It all depends upon your practical scenarios. When we start talking about an use case which we have covered in this course, we will be explaining you where and how to use NumPy, pandas and various other libraries. That's all about NumPys. In the next video, we shall be talking about matplotlib and seaborn libraries. Thank you.